Hi, in this video, I want to take a relook at the diode VI characteristic. You remember a few videos back, we had taken a look at the diode VI characteristic and said that in the ideal case, the characteristic looks like this. So when voltage is across the diode is less than zero, we are in the reverse bias and the current is almost equal to zero. And uh, when we are in the forward bias, that is when the diode voltage across the diode is positive, the current is basically it's closed circuit and the current is infinite, and the current is not determined by the diode itself but by the external circuit. Okay, but this is the ideal diode characteristic. What happens for real diodes? So this is what a real diode characteristic looks like. Okay, let's look at this picture first. So in the forward bias, yes, the current rises very, very steeply, but it does not rise exactly on the y-axis, right? There is a small voltage here before the diode starts to voltage starts to rise, and this voltage is usually around zero point 0.7 volts. Okay, in the reverse bias, we have almost zero current, but this zero current does not persist forever and ever. So at some point, when the reverse voltage across the diode increases beyond a certain limit, the diode actually breaks down. Okay, and the current then starts to increase, and this current is called the breakdown current. Let's look at this characteristic in a little bit more detail on this graph. So what I've done in this graph is I have taken the negative x-axis and compressed it. Okay, we have just compressed this scale here, and we have expanded this scale so that we can see what's the current flowing through. And what we see is that the current that flows in the reverse bias is not zero. It's a very small current, but it's non-zero. Okay, and at some point the current increases, and this increase happens in the breakdown region. And in the normal diode, breakdown is usually irreversible, right? So basically the diode has burnt up, it's got spoiled, and it won't work like a diode anymore once you enter the breakdown region. Okay, so that's breakdown. This is the reverse bias region, and in the reverse bias region, as we said just a moment back, that the current is not zero, but it's very small but finite current. Okay, and in the forward bias, you don't have immediately have a current that goes up like this, but it takes a bit of time before the current starts to pick up. And this voltage is called the forward voltage of the diode, and you can assume that the current actually, the diode turns on not at 0 volts, but it turns on when the diode voltage is greater than zero point 0.7 volts or something like that. Is that all right? Okay, so let's just give a little bit more details about this. So some of the things that we can note is the diode current is given by this equation. Okay, so where V is the voltage across the diode and I is the current through the diode. Is a constant and Vt is a constant, and usually you take the value of Vt to be around 25 millivolts. You can look that up in the notes. Uh, in the reverse bias, the diode current is usually written as it is approximately equal to minus Is. Okay, and in the breakdown, of course, we don't really want to go into the breakdown mode, right? And the current just increases very, very rapidly in the breakdown mode. So you can see how the real diode characteristic is different from the ideal diode characteristic.